Okay, for people who are joining this live stream, we are talking about incremental language development for Wolfram Language, and we've got a bunch of different items to talk about. So first thing is geoposition and threading. So the issue is...
Right, so first we explain here why geoposition needs to have so many lists inside. It's coming from the polygon structure. And then there is a proposal for a new threading function. So,
okay. So the main issue is if I were to say something like, if I were to go ahead and say something like geoposition of something like capital cities in South America. I'm just going to try and work this through. So I'll get that. Okay, then this will generate that. Then what we'll get is that. Okay, now if I want a function to operate on that, if I say find shortest tour, it probably knows how to deal with that. It does.
Correct.
But in general, if I want to see those geopositions separately, what do I have to do?
Right, because in this case, it's just a list of positions. We can use just thread.
Okay, but does that work? I mean, I would never have thought to do that, but yes, okay, fine.
Right. Now, the problem is that sometimes your position contains a list of lists, and then we need deeper threading, and thread cannot do it.
Why does it contain a list of lists?
Because we have this idea of polygon of geopositions, and polygon can take multi-lists. So geoposition needs to take that as well. So that example of the US shows that. So you see that we have nearly 3,000 points separated in 3 lists. So if we thread once, we get the 6 lists.
I see. So in other words, those are 6 non-contiguous parts of the US. Is that what you're saying?
Exactly. Yeah. 3 independent non-overlapping polygons.
But so the internal structure of that, if I say input form of %1 here, the internal structure of that I see as a geoposition of lists.
Exactly. But in other cases, it will be a deeper list. And then thread, because thread can only thread through one level, it gets complicated to thread.
And I understand. What does normal do?
In this case, nothing. This is a separate discussion of whether normal should do something on geoposition. And because it could do several things, it's not so clear.
I mean, I would have expected it to just unravel the thing, but
one level, several levels.
Okay, well, let's see your proposal.
Yeah, so here, for example, if we have to thread through the 2 levels, we need to use thread twice.
I understand.
And then this section is a bit of explanations of what thread does.
Yes.
And the main limitation of thread is that it can only thread through one level. And map thread, for example, has a third argument in which you can specify how many levels you want to thread through. But it has a different structure. You have to separate first the head, and it really requires lists. If you have something else, like in this expression with heads H, it doesn't work. So map thread is not the solution either here.
I mean, any of these things is fairly obscure to know, but okay, all right. So let's say proposal for a new threading function.
Yeah, this code is obscure. It's just I took code of something. It's just evaluated. So for example, and so this comes from another operation, which is a generalization of transpose. And so this is the idea, and the name is totally tentative. So here we say
kind of fun and not alliterative, but it has some rhyming character, head thread. Okay, go ahead.
Mm-hmm. So here we are specifying how many levels we want to thread through. In this case, 2 or 3.
Yes.
Huh?
But so in the case of geoposition, would it know how many levels geoposition likes to thread to?
Well, in principle, ideally, we would thread the minimal possible, because it's important to keep packing for fast operations. So that's why we keep the geoposition head outside. So that's why I don't want to thread all the way down. And if it's possible to specify how many, then that will be better. And now this function for which I don't have a prototype, these are just fake examples, is the general case of threading, in which you specify it has 4 arguments, and you specify the expression, the number of levels you want to thread, the function that should be threading, and the function it should be threading through. That's the general case. And so we need F and G.
Okay.
And so the relation with thread, I think it's in the previous subsection.
Okay, but so let's talk about the geoposition case.
Yeah,
How would head thread solve the geoposition case?
Well, one would say, oh, I have a geoposition with so many levels inside. I want to thread through.
How do you know how many levels you have?
Because it's written in the in the summary box.
But that's annoying. I mean, look, this country happened to have islands. This country didn't happen to have islands. That's a very obscure thing. There
is a property also, because geoposition has properties. One of them is depth, and it will tell you how many levels it has. In case
what about having a property of geoposition? What about solving this problem for geoposition by having a property of the geoposition, which is the unraveled version?
We could do that as well, yes, but still we need to specify how many levels you want to unravel.
Well, okay, so hold on. Let's imagine. Let's take a look at the properties of geoposition. But I mean, let's say individual points or something.
Do here of geoposition, for example, of properties. Sorry, they are listed in the details as well.
You're saying this?
Yeah.
I didn't know those existed.
These are new in 12.
Oh.
We did document them together, but yeah.
Where are they documented here?
Yeah, that list at the end.
Wow, that's cool. Well, by the way.
Mm-hmm.
Okay, all right. This never made it into the new in 12 list. That should be, somebody needs to go edit the new in 12 list and add this. This is so embarrassing. We have so much new functionality that we keep on forgetting to add it to our new in this version list.
So I thought I saw this in the new in 12 list. At least one of them somewhere.
Okay, well, if it is, it is. I didn't remember it. Okay. Okay, but so here, what I'm suggesting is that what we would do is something like we would have points and we would have regions or something, just like, and points would resolve all the way down to the individual geopositions.
I see. So different names for the different.
Yes, because that way, a little bit like the way that the OSM database is organized, that we have something where you say regions, okay, great. It'll just give you a list. If it's a country with a single contiguous section, then it'll just give you a list of, you get what I'm saying.
Mm-hmm.
This seems useful to me.
Yes, we can certainly have those properties. I still think that it would be nice to have a more powerful threading function, because this need appears in other places.
No, I agree. So let's agree on first point is geoposition will get these things that say points and regions and so on. And by the way, don't forget, like here,
mm-hmm.
It will be good to put in the
predictive interface. Mm-hmm.
Yeah, right. What that's interesting that works.
Yeah, so those are the respective attitudes.
I wonder what happens if I say geoposition of 0.5. It just stays as a geoposition.
Yes, but you could thread first and then do geoposition, and it would collect them again.
Okay. And let's take a look. I see the second argument is a datum, which is kind of a useless thing. Don't other functions have datums as options?
We call it geomodel in other cases, yes. But for geoposition, it's fundamental. For the other functions, it's kind of informative at the beginning to know what they have to do.
I see what you're saying. If this is a grid coordinate somewhere, it's just totally different meaning than if it's a lat long.
Exactly. In fact, the meaning of lat long depends on the datum. In different datums, the same place will get different numbers.
Fair enough.
It's like the projection in geogrid position. It's still an argument, even though nearly most other places it's an option.
Okay. If you gave a geomodel here, would it absorb itself and become that second argument?
No.
Might be a nice thing to do. Yeah, but that's a minor thing.
Mm-hmm.
I mean, because if I were to say a geoposition here, a wrapping geoposition with a new datum, what would it do?
It will change.
It will inject the datum.
Yes, it will perform the change of datum.
Oh, really? Does it document that?
Yes. Probably in a note.
Datums. There we go.
Yeah, exactly.
Okay. All right. So I think with geoposition, that's okay. So let's talk about the threading function, which I think nobody is ever going to guess in the case of geoposition, but that doesn't mean we shouldn't have such a threading function.
Mm-hmm.
All right. So let's take a look at your general case threading function. All right.
Yep.
So it's an expression. Well, let's look at thread first.
Exactly.
Thread is a very old function.
Yes.
Gosh, it hasn't been modified since version 1. It has the weight of history upon it. Okay.
I think in a sense, the modification of thread is map thread. Because it does a very similar thing in a more powerful way, but still not fully general.
All right. So thread in general has a head specification, which is which one of these?
G. It's G.
Okay. But this thread has a take spec here that you don't have in the case of head thread here.
Exactly. Yeah. I don't find it that useful. But yes, it's true. That's a difference.
I think it is sometimes useful, but I think it's a different use than some of these other things.
Exactly. And it's in fact why I'm not suggesting to generalize thread, but to have a different function to avoid confusing the two ends.
Okay, so let's take a look at what you're proposing here. So,
most important thing is the fact that you can thread several arguments, because the function thread can only thread one.
You mean by several arguments, you mean that
several levels. So for example, in the first example there, head thread, F is pushed 2 levels deeper.
Yes, I understand. Do you believe in the name head thread?
Not really, no. Ideally, this would be the thread itself, but if we add another argument, if we add the
totally obscure.
Yeah, it's going to become a 5-argument thing, which is so difficult. Yeah.
Well, I mean, thread is perfectly useful
It is.
And it's occasionally used with its second argument, and I have seen it used with its third argument. So I don't think we should knock thread especially, but I think the okay, so you're saying, I don't quite understand. Okay, so that first thing says, okay, so you're taking the outermost head and you're pushing it a certain number of levels down, right?
Right.
Okay, so if I were to do this, if I were to say that comma list y.
No, this function is not yet prepared for that.
Okay. But so if I were to put a bit more encrusting here, would that work?
Yeah.
Okay, so let me understand what this did. So this is a tree This is pushing that function down in this tree.
Right.
So if I were to look at this as a tree, we should consider making tree form more beautiful. Because this business about it saying list all the time is just really ugly. I wonder if there's a better way to do that. I mean, I wonder if we should have a way, just a better visual way to indicate this. I kind of think our neural net functions have solved this to some extent. Can we ask the neural net visualization folk whether they've got a partial solution to this? Because I mean, I think the main issue here is that node is just way too heavy, saying list there. Well, did you agree or not agree? I mean,
so you're thinking like braces with a placeholder in it or something, or
maybe something like that, or just something more lightweight, because it's just so heavy and it's so, it's talking about a structure that. Well, anyway, I just think that's some. Okay, let's see. Okay, so let's see here. Okay, so that's what we did there. Right, we transformed one of those to that.
Mm-hmm.
So it's an operation that pushes a function down into a structure, and the structure should be a somewhat conforming. It has to conform at least up to that level. In other words, if that level didn't exist, we wouldn't be able to push it down.
Right. If the function has several arguments, the arguments need to have the same head and the same length. That happens already in thread.
You see, but thread, its main function is to thread across arguments. This function you are proposing, if you think the one argument form, f of one argument is going to be a useful form, that's a slightly different way of thinking about it.
Yes, I'm thinking of the particular case. I mean, the general function I'm proposing should also be able to handle several arguments like thread does. But thread can also work in one argument.
Right. So in the geoposition case, what would you actually do? If you want to get, let's say you have the US and you want to get the points in the US, you would say head thread of that geoposition, 2. Is that correct?
Right. And for example, imagine that the geoposition had a datum. Then we would have to replicate the datum in all the internal geopositions.
Yeah. So what's your point?
That's why we need to also worry about the head we are threading through, because it has to be list. That happens already in thread. So this h in the second argument is telling us thread through the objects with head h and consider the rest as scalars.
Fine. So in this case, you're saying you would promote the level argument to the second argument. And I mean, it's not thread all, is it? No, it isn't thread all.
No.
I mean, I generally like the idea of this function. Okay, so it would default to list being the head.
The head you thread through. But I also want to specify the head I want to thread.
I agree. Which is the h threads f here over any objects that occur. So you're specifying what that f is, because that f might be, if I'm understanding correctly, that f might be at a deeper level.
Exactly. For example, the operation of thread cannot be inverted, because once you have pushed f deeper, now how do you bring it back?
So you are imagining a negative thread that brings it back.
Exactly. So those are the examples there. You specify the head you want to push and how many levels. And in the general case, through which functions you want to push it. Right. So let's talk about how
I agree with this function. I think this function is a fine function to have. How on earth do we name it? should we think about it? I mean, so it is in the family. You see, threading I always view as being a threading corresponding things through.
Yes.
If I'm making sense.
Yes, that's the role of F, and that's why map thread has that name. Yeah. But map thread, for example, doesn't have the G freedom. And so if you put things with heads other than list in the second argument of map thread, it doesn't work. And this has been a generalization that has been requested in the past.
So in other words, an argument, so you're saying that this would then have the argument structure would be N here, and then the F is in a different place from the way it is in head thread because it means something different. But then you're saying a comma H there after the N that represents what you are. No, I'm very confused. That says the second argument, forget about it having lists in it. It's okay if it has H's in it. Is that what you're saying?
Right. So if it's obvious which ones, for example, imagine that the expression 1, expression 2 had head H. Then map thread wouldn't work. It will consider that they are scalars, so it cannot thread through.
Okay, so hold on. If I say H of...
No, list of H of 1, 2, H of 2, 3. Yeah.
Okay.
Right. So this could have returned H of F1, 2, F of 2, 3. Sorry, it was a bad example. It's changed to the second 2, 3 to 3, 4.
Okay, now why doesn't that work?
The outermost list is just a container. It's not going to be reproduced in the result. So the outermost list is kind of irrelevant. It's the inner ones that are important.
Okay, so you're saying in your Hified form here that you would expect that result to be H of F of 1, 2, F of 2, 3. Is that right?
Right, yes. But sorry, I think we should use 3, 4 in the second because otherwise we're getting confused.
Why does it make a difference?
Because we are getting the same result back and it shouldn't be. Exactly, so now it's clear.
Oh, I see. Yes, I get it. Okay, so then this is 1, 3, 2, 4, where that is now, I see, it's now applying the H. And clearly if we had deeper levels, we would have nested H's. Is that true or not?
Yes, indeed.
Well, that seems like a reasonable generalization of map thread. But Sandra on our live stream is suggesting thread down as a possible name. Or rethread. I'm not getting that. I'm not really getting the thread idea here. Because threading, as far as I'm concerned, is you take multiple objects and you are threading a function through those multiple objects. I mean, I would say the quintessential thread case is something like, thread in F of, A, B, C, D or something. I mean, it's the listability. We're just implementing listability.
Indeed.
And okay, so the question here is, what is the operation that is pushing that down in the tree? How to think about what it's doing? I just don't think it's threading. I think it's some kind of.
This function will be a generalization of thread in a sense. So it will also be able to handle several arguments, and then it will be a true threading.
Yeah, I understand. Well, there's weird possibilities like thread inside. Because what this does, the difference from thread initially, is that this is capable of doing sort of multi-thread, so to speak.
Yep.
I mean, in other words, it can do a threading that is down at that level.
Mm-hmm. In a sense, this is also a bit like inner, in the sense that it has the same FG functions. So inner thread, deep thread.
In what way is it like inner?
Inner has also the freedom of F and G. And in fact, I'm always trying to be consistent in the naming of F and G. And many of our functions have FG freedoms, and they mean the same thing. F is always the threading function that takes multiple arguments, and so it's a bit like times, and G is like list or plus. The function that collects at the end.
Right. It's like the MapReduce story.
Right. So yes. So here you see the relation with the previous case that we were discussing.
Yes, that is interesting. Do we make it clear that that's, yeah, we do.
So a few meetings ago, we discussed this generalized function I have called array contract thread, which is kind of the super general concept of threading. And all of these other functions, thread, inner, map thread, dot, outer, and this one as well, would be particular cases.
Can we see that function? Can you remind me what that function looked like? Does it have what parameters does it have?
It's implemented in the symbolic tensors context. And it's called...
is there documentation for it?
No, I don't have documentation, but I can give you an example if you want.
Yeah, okay.
So if you
write symbolic tensors.
Symbolic tensors array contract thread. And then it takes the F function, then a list of arrays. So let's say, yes, A, B, C, D. And now a list of contractions, which would be like list 1, 1. And then G, comma G.
Oops, what happened here? Oh, symbolic tensors.
Okay, that's it. So this function has 5 arguments. It has the F function, the list of arrays, the list of contractions in the notation of tensor contract, the G function to collect them, like inner, and then a 5th argument, which is what I call the effective depths. It means go down in the arrays up to this level, like outer dash. Do you remember
yeah, I remember.
The number arguments.
Kind of a hack, yes, the outer one, because of the Verog's character of outer.
Yes. So here it's a list of numbers rather than bar arg. So it's a 5th argument. But it's the same idea. The idea that you are dealing with arrays and you say, no, treat them as arrays only up to level n.
How widely? So tensor contract takes a single tensor. What does contract do? Does it by default it adds? What happens if I want a different operation than adding?
Tensor contract is the mathematical version of this, which can be symbolic as well, can stay there waiting for other operations. So it only supports F equal times and G equal plus. But do symbolic operations.
Where's the times coming in?
It's like outer. So in the same way that tensor product is the times version of outer.
Yes.
So tensor contract, again, is like inner, generalized to many arrays and any depth, but it only supports plus and times.
I hope it doesn't have an application section from like the Riemann tensor or something.
Yes, I could add examples.
We could, I think. But okay, but so this function
function is saying you take the data array there and contract the second level and the third level of the array.
Right.
And if you have many, you can, what needs to be done is to first have the tensor product of that, inactivated if needed, to avoid the intermediate as well.
Right. Someone is asking on live stream, why are there functions without documentation? Because these aren't real functions yet. These are just experiments.
Right, they are in internal contexts.
That's what we want to do, is make them to the point where we think the design is right and we can go ahead and document them. Okay, so are you saying that thread inside, or whatever it's called, is a special case to array contract thread?
Yes. But I think it's simpler to understand.
Which is simpler to understand?
The map head thread inside.
Okay, so in what sense is contraction? How does contraction relate to flattening?
They are independent operations. Contraction. The general idea of contraction is that of having an array with multiple indices and doing something to pairs of indices.
Whereas flattening takes, for example, pairs of indices and unravels into a single index. I mean, what flatten is doing is to take something that might have two indices and unraveling it so it just has one index.
Right.
Whereas what you're doing here is to take those two indices and you're getting rid of one of those indices by knitting the things together using, multiplication and addition.
Right. In general, contraction gives you smaller things. And I guess that's the origin of the word contraction. While flattening is the same size, but just rearranged.
Right. So if we compare the flatten of that, and now can we do a contract of that, tensor contract?
Yes, you would have to say levels 1 and 2, because it only has 2.
Okay, so I say 1, 2, like this.
Mm-hmm. So that's a trace.
Wait a minute. So in Einstein notation, something that would be T mu mu. Is that right? With the repeated index convention for contraction.
Right.
So is it always the case? Let me try to understand. By the way, is there a generalization of the Einstein summation convention so the Einstein summation convention is always pairs of indices because we have this notion of covariant, contravariant things. But is that generalizable to triples of indices and things like that?
Yes. The algebraic interpretation would not be that clean, but the operation itself, yes. And we have it with trace. So you can do trace with 3 levels, for example. Do not in that array, use a bigger array.
Yeah, so I want an array of depth 3, for example. Let's say a 3 by 3 by 3 array.
Exactly. And now do trace of that.
What do I have to say? Matrix trace?
No, trace, TR.
Oh, TR, okay.
TR of that array, and I think you have to say G, 3 or plus, 3. You see, it's doing essentially in Einstein's convention, it would be I mu mu mu.
Why is that giving the same result?
Because I think by default it traces as much as it can.
Okay, so the alternative would be a level 2 trace.
Right.
Which looks like that.
Right. So it's tracing only through the first 2 levels. That's another thing. You cannot trace through levels 2 and 3. It has to be the upper 2. So another natural generalization in this function would be having a list of which levels you want to trace.
Does that make sense? I mean, but that's then a contraction. I mean, you could represent that as a tensor contraction, correct?
Yeah.
So in other words, your trace here is the analog. If I'm to do this, except tensor contract doesn't have a G function, it just has plus. If I would have that, and then this would be a contraction of all three of those levels. Is that right?
Yes.
I see. So that is the way in which we generalize the summation convention to allow ourselves to have a triple, triple matched indices.
Right.
Okay. All right. So let's come back now to what you're saying with array contract thread. Well, actually, let's come back to understanding this. What is this thing? What is this operation? You are exchanging, you're pushing a head down. What is that operation? Gosh. It's not a map operation. What operations rearrange the levels of an expression? So in other words, if I say f of g of h of x, what operations do we have that rearrange that to be an h of f of whatever?
I mean, it feels a little bit like commuting diagrams.
Interesting claim.
I would say the idea is transpose. It's just a transpose. We always transpose in list and list, but we could transpose other things. And that's the function I had above in the code, what I called a general transpose.
Wait a minute. So in addition to array contract thread, and by the way, I want to store these someplace.
It's miscellaneous.
Is that the best we can do? All right, let's call it, what are we going to call this? Thread generalization.
Okay.
Oh, wow. Okay, so what is this other thing you're talking about here?
You were asking what's the general idea of moving heads up and down. And yes. I think it's a transposition of the levels.
But we don't have, as you're pointing out, we don't have the transpose that we have merely rearranges elements in lists. It does not allow us to transpose with things other than lists as heads.
Yes, but the functions you just evaluated, the code you evaluated a couple of sections ago, was a general transpose that does that.
Okay.
A bit further down, that code. So that general transpose takes an array of any heads and it will move them around.
Okay, so if I were to take this and I would say general transpose of that.
Yeah. And do now like 1, 3, 2, for example. You see, it moved H and G.
Yeah, I understand.
And it will work as long as things are rectangular.
Right. And if they're not rectangular, by the way, it could very well be useful to have a version that has missing element insertion.
Yes, that's another thing. That's a rugged transpose.
Do we have such a thing?
No, but it's easy to implement. That's a function used for transposing Young tableaus.
All right. So right now, transpose has 2 arguments.
Yep.
And the transpose that we have, those second arguments, N1, N2, etc., those are the level specifications. So if I were to do this, not very usefully, but if I were to say transpose, and again, it's not going to be very useful in this case, something like this, 1, 3, 2, although you can't see it because they're all just lists, it's going to be rearranging those lists around, right? So why is it that we don't make transpose work on heads other than the list?
I think because transpose comes from a rather mathematical area in which people are always thinking about lists. And
we could make it work for this case.
We could, but of course, it's one of those cases in which we run into what's a scalar. I mean, it cannot be by default, of course, but because now we have the allowed heads option, we could play with that.
We could have allowed heads as an option, or we could have it as a third argument.
It's an option already in transpose.
Oh, really? So
Yes.
if I say, if I were to say transpose of, if I were to take this and I were to say allowed heads arrow blank or something, allowed heads arrow all.
I mean, it's not implemented. It's implemented for association and the first two levels. That's why it was introduced, to support transpositions of lists and associations. And that works.
Okay, but we could perfectly well make this work too.
Yeah, indeed.
Okay. Yeah, Sandra on the live stream is pointing out that flatten can handle some ragged cases. Yes, that's true. Flattening is easier with respect to raggedness because transpose actually requires, I mean, what we would have to have is an option here that says, what would it be set? What would it be called? It would be something like a missing function or something, which I think we have. Don't we have that? No, we don't have that. We what it really should be is something which is a thing which depends on the index and says what to put in at that position. In other words, given the synthesized index, what should be there? And it could just be it's always 0 or something, which so 0 ampersand, but it could be that you actually do something that depends on the destination index, the destination position.
That's true. There is also the approach in Young tableaus, which is that as long as things are aligned to the left and to the top, the operation is doable because the result will also be aligned to the left and to the top.
I see what you're saying. So ragged to ragged works.
Right. In some conditions. I mean, for example, if you have an empty row, when you transpose it, it will disappear, things like that.
Yeah, that's complicated.
But the case handled by these Young tableaus and I think in the general case they are called Ferrer's diagrams.
Yeah,
that can be handled.
Okay, so that's an interesting thing for us to do, is to have some kind of raggedizable transpose, or maybe transpose itself becomes raggedizable. I say, okay, so there are two cases for ragged. There are two ragged cases. Some ragged arrays can be transposed, can meaningfully be transposed on their own.
Right.
Some require explicit insertion of missing elements.
Yes. Yeah, I think the condition is as long as the following row is not longer than the previous row, and the same for columns, this can be done uniquely.
Sorry, as long as the what?
Yes, if you go down through the rows, they cannot be longer than the previous ones.
I see. Makes some sense, yeah. Let's see, we've got several comments here. One comment on the live stream is about array reshape, and whether this can be put as a generalization of array reshape. That's an interesting idea.
I think array reshape belongs more with flattening, with the idea of keep the same elements but in a different shape.
Yeah, you're right. However, array reshape is also something which could have missing element handling.
That's true, yes.
Oh, actually it has. Look, right there. It already has it. Padding.
Oh, with padding, yes.
Okay, so that's worth us remembering that array reshape already has a that's actually a nice feature. Okay, next point on a live stream Comment, it would be nice to get a documented version of normal at query of transpose. What the heck does that do? What does that do? Oh my gosh. That's a horrifying thing. What is that?
I think this is the idea of transposing associations, which is what we wanted to achieve with transpose of allowed head list association.
But what's this thing? What's this crazy creature that just popped its head out, so to speak?
Oh, well, this is some sort of compiled forms of the queries. So for a query, you can do normal, and it gets transformed into something else that is what internally.
Oh boy, this is a can of worms.
Yes, we don't want to get there now.
We should discuss this at some future time. This is. But this particular operation, this association transpose operation, we have chosen for right now to make that into the allowed heads operation. So that becomes, this is effectively transpose of hash, comma, allowed heads, arrow, something. What?
Yes, list, comma, list, comma, association, exactly. This will allow heads, list, and I think this works if you try it with a list of associations.
Fair enough. I mean, whether we want to repackage that as an association transpose, I'm not sure.
We could. It has been suggested a few times, yes.
I mean, it's been suggested enough times. I think maybe we should actually just do it. Let's review that possibility, okay? That we actually have an association transpose. Okay, next, a livelier question. Can this be generalized to n-gon-shaped data structures, for example, hexagonal arrays? Oh my gosh, that is such a can of worms. We have been messing around with those things for 20 years. We would love to just have a, like for instance, if we say rule plot of something like cellular automaton, whatever, and then we say, what is the option here for rule plot? It is
appearance, maybe.
Yeah, that's right.
I haven't looked at a rule plot in a year or so.
Appearance, arrow, hexagons. Okay, look at that. And therein we start seeing the trouble. Because where do you put that second hexagon? I mean, this is the beginning of a slippery slope of horrors. That there are just many, many, many issues with. But I mean, we have wanted a hexagonal, or in general, a lattice plot for many years. And I think we've systematically failed to find meaningful ways to deal with it. Like for example, whatever the data is, I don't even know. Maybe we just talk about this for a second. I mean, whatever the data is in a hexagonal array, it's not representable by, well, maybe that's the point that's being made on the live stream. It's not representable easily by a rectangular list of lists. What on earth is it representable by? Is it a graph of some kind? What is it?
I mean, a graph form would certainly be unambiguous, I would think.
But what would the graph be? So it's a hexagonal. It's a hexagonal boundary array of hexagonal elements, for instance. That would be one example of a configuration, right? But what is, because the other example is a rectangular boundary of square elements, right? So the question is, what is the consistent boundary of a thing with hexagonal elements? And the problem is, you can't have, I mean, you have to have this weird business with even and odd rows if you're having, I mean, this is analogous to, so another case of this is bricks. So that looks like that. Another totally weird thing. Because that's dealing with pairs. Right? Am I making sense? I mean, so it is an interesting thing. Is there a meaning to non-rectangular arrays that isn't totally? What is the appropriate way to think about a non-rectangular array? Has this come up in general relativity settings, Jose?
Not that I know.
So a tensor, what would be the reason to? So a tensor generally has. See, here's where it would come up, right? So yeah. Okay, so here, let me ask you this question. So a normal tensor is a Cartesian tensor. Its indices represent lattice directions in Cartesian space, right?
Okay.
What if you have a tensor whose indices represent r theta phi in spherical coordinates? What is that?
Well, in the end, we are always mapping to something rectangular. So even when we have this r theta phi, we're still thinking of the r axis, the theta axis, and the phi axis.
But we shouldn't be, because they're cyclic, for example. The theta axis no longer has the topology of a Cartesian space.
Yes, but the tensors don't live on the sphere itself. They live on the tangent space, and the tangent space is infinite.
I see. So your point is, in the world of differential stuff, that you're always dealing only with the tangent space, which is by definition Cartesian.
For the tensors, I mean, you may have the positions. The position objects deal with coordinates, and those are cyclic. But once you go to the tensors, then no, you're always in the tangent space.
Fair enough. Okay. I mean, this has come up. This business about hexagonal grids has come up over and over and over again, and I don't even know. Honestly, I don't know. So I think in a lattice there clearly is a way of doing positions in a lattice that is the analog of, positions correspond to the given the basis vectors in the lattice, right? Isn't it a feature of a lattice that to get to any given cell in the lattice, there's a unique set of integers by which you multiply the basis vectors to get to that point in the lattice? Is that not the definition, basically?
I think so.
And then I think in crystallography, that's related to things like the Miller indices and things like this. But go ahead. You were going to say.
I'm thinking that in geography, there are representations of the Earth based on hexagons that become smaller and smaller and smaller. And there are some sort of algorithms to name all these hexagons by letters and numbers. So this avoids all the problems we always have with periodicity and the poles, etc. But why
does it help? Why does it help to have hexagons? So in other words, you're tessellating the sphere with hexagons, which obviously doesn't work. I mean, it no more works to tessellate with hexagons than with squares, does it?
Well, it cannot be done exactly, but if you start with, I mean, it's the same thing we do with sphere points, I think, or the discretization of a sphere. There are some pentagons there sometimes, but most of the times it's hexagons based or triangles.
So you're saying that there's a way of addressing. I mean, it's like this crazy what three words idea where you have, where your front door might be, elephant, shoe, chair or something.
Right. Yeah.
I mean, that gets totally weird. I mean, that's basically a UUID for every point.
Right. It's a very ad hoc thing, I think. I'm not sure it can be generalized to other shapes.
But what is the way of thinking? And this is a bit of a sidetrack, but I'm just curious about it. I mean, what is the way of thinking about a lattice? Is there a way of thinking about it in terms of graph, or what is the way of, or is it simply that the lattice has, the lattice in n dimensions? I see. The real problem is this. The real problem is, let's say you've got a hexagonal lattice. Your basis vectors are not orthogonal. Fine. No problem with that. The difficulty is that, yes, if it's an infinite lattice, there's no problem. But if it's a finite lattice, understanding a container into which you can put the thing, because the thing is going to be, it can have a hexagonal outer boundary, or it can have some wavy outer boundary. It's just very unclear what the limits on the indices look like and things. Is that right? And you'll have weird things like that for even numbered x coordinates, the y coordinate goes up to this, and for odd numbers it goes up to one different, which is really kind of weird. And that is hard to represent in something that is something like a list of lists. So I mean, the issue is we're mapping to trees in okay, let's try to understand this. Why do we have, the issue is that, well, I mean, the thing I just described doesn't in and of itself cause trouble, because we can represent, I mean, in some lower level system, we might not be able to do this, but we can perfectly represent a ragged array where we have where it's like ABC, AB, ABC. We don't have any problem with a thing like that. I mean, many of our functions don't work that well on it, but we can certainly represent that.
Mm-hmm.
Yeah, I mean, we've had a number of summer school projects on attempts to make kind of lattice plot, even lattice plot, where the quintessential case of this, and we're now seriously off topic, but I'll just show the quintessential case of this is, let me show you this. So in here, there is an example, I think. So if you look at other geometries, here we go. So this is for example, these are 3D geometries, right? So these are what are they? The Bravais lattices or something. These have certain unit cells, right? And then the question is, how do you represent? How am I saying this? Am I making any sense here? I mean, this is the problem is how to map the values in here into a grid that you can do computations on, because the neighbor structure, that's the issue. Some of these have like 12 neighbors, right?
Right.
So the Kepler packing has 12 neighbors, which is what is that? That's a rhombic dodecahedron, I think. So that could be represented by a graph in which everything has 12 neighbors. Yeah, that's the problem. The problem is, and we don't have, so the generalization of our operations, all the transposing and so on, we could generalize those. We are working on trees. We could in principle generalize those operations to graphs, but that's its own complicated story. Does anybody know how this represents? Okay, Brett, you made a comment about commutative diagrams. Can you expound on that? How does this relate to the category theory world?
No idea. I mean, I was thinking my connection to commutative diagrams was just sort of, the simple, rectangle where if you go down and over, or you go over and down.
Yeah, right. But that's where the whole generalization of that is the whole story of category theory, and those things. And I don't know. Does anybody in this meeting know about that?
No, I cannot comment.
Okay. Wrong set of people. We have probably other people who know about it. I've just recently, I mean, the whole world of category theory, which started off as kind of a wrapper around algebraic geometry because it was hard to sort of see how to transform ideas from one area of algebraic geometry to another, got picked up in more recent times in the type theory business, and in yet more recent times in this sort of weird convergence with Petri nets and with quantum computing and with blockchain stuff. It's a very weird set of convergences, but really quite interesting. But I don't think I understand it yet. Actually, Zudark on our live stream is commenting that he's run into the hexagonal array stuff in computational optics for non-isotropic materials. And Sandra is commenting the extension of Miller indices is the Miller-Brave indexing system used for hexagonal lattices. Yeah, that's right. I mean, the Miller indices in general represent, those come out because people actually see spots in X-ray crystallography pictures, and those can exist for any. That's the point. Those are the coefficients of the basis vectors in reaching a given point in the lattice. All right, so anyway, that's a separate discussion, which will be interesting to have sometime, is the generalization, is the whole lattice plot story. I really would like it if one day we can actually, 20 years I've been thinking about this lattice plot thing, and we just don't have a solution to it. We should put that on our list of things to look at. I think it has been on the ILD list for a while. But let's come back to our needs here. So the issue is we've got this operations that we've got your array contract thread, which is a generalization of contract, tensor contract, that is, as you say, insofar as, we have a Kronecker product, don't we? Which is like an outer with particular mathematical operations, right? Or tensor product, right?
Yes. The tensor product, Kronecker product are variants of outer.
Right, exactly. But what you're saying is that tensor contract is to this new function we're trying to create here, what, for example, dot is to inner, right?
Yes, that function you just selected, I think it's the most general case of contraction. And then we have other subcases, and I'm suggesting one more subcase, which is this head thread.
Okay, fine. All right, so first point is the array contract thread idea, which seems like a good idea to have this generalized function. But now how does it specialize down to head thread? What's the argument structure here that leads it to be head thread?
It's a special case of choosing the third argument. I would have to think about it, but it has the F and G freedoms are exactly the same. And then the list of arrays there would be the arguments of the initial function.
I see.
And then the third argument is something special, but I will have to think about it.
Okay, right. But it's a thing where instead of you laying out the thing you're operating on in a second argument, it lives inside the first argument, so to speak. And this is kind of how to find the places that you want to do things at.
Exactly. The difficulty in using array contract thread is how to choose the third argument.
Right.
You have to choose the numbers carefully, while this new function is just a single number that tells you the level you want to go. So it's a lot simpler.
All right. Okay. What are we going to do with? Okay. Let's talk about array contract thread.
Perhaps I can put it in some other context or add some documentation to it well,
perhaps you can just put it in the function repository and just have it call into this internal function. But also, is there a good reason why we can't just have an array contract? Well, it's not contract, is it? It's not really contraction. It's not.
Well, I have another symbolic tensors array contract, which is the general case of a single array. It's some sort of generalization of trace.
Okay, but the word contract, as you say, comes from, when you're using F and G, there's no contraction involved. Nothing is contracting. It's not squashing it, is it?
So the F function is the threading function, and the G function is the contracting function. If you want to.
Well, it's like a map reduce. So the F function is mapping, and the G function is reducing, isn't it?
Right. Exactly. Yeah. So like in inner, it's clear. So F is going through the elements through pairs of elements of the two arrays, and then plus is summing, is reducing them to a sum.
Well, yeah, I understand, but I'm saying the word contract comes from the idea that you are getting rid of indices, right? contraction in a tensor, mu mu just disappears, for example.
Right, correct.
But in this case, you're not getting rid of indices. You're simply rearranging things, right?
It depends on the function g. So plus, when g is plus, is the function that is doing the contraction.
No, I understand. Okay, so what you're saying is that g, if g is a function that scalarizes, then you are removing tensor layers.
Exactly. But if it is least, for example, then you are not.
Or even just a general symbolic thing, you're probably not.
Exactly.
Okay. I mean, arguably, just as outer, comes from notions of outer product. I don't know. Okay, well, anyway, the other thing to name, Carl has just joined our live stream and says he has many opinions about geoposition. And yeah, well, mostly we're talking about how you take a single geoposition and turn it into individual points or individual regions. So if you have strong opinions about that, you should let them be known. If it's about different things to do with geoposition, let us know about that too. Okay, but anyway, back to this. So, okay, first question is the original operation we're talking about a thread inside type operation? Is thread inside a plausible name? What is the description that we would give to this function? So we would say, do you have a proto documentation for it?
I wrote something there. Further down. There, threads the head F. But yes, it's true that it's not really.
It's not threading.
It's thread if the expression has multiple arguments.
All right. Now let's talk about how it's more like transpose, isn't it?
Yes.
Your generalized transpose here.
Mm-hmm.
How? Yeah, that's very similar to this function, except for when the function has to thread, right?
But thread has the same situation. Thread can also act like transpose.
Yeah, I understand. I mean, if I say thread of that will just transpose.
Exactly.
All right, so how many functions do we have to name? Are we also talking about your one argument form of array contract thread, or are we not talking about that?
Well, I think these two very general cases are difficult and shouldn't be system functions. But this new threading, I think it should be a system function.
Are you sure this one shouldn't be a system function?
Well, I mean, I'd be happy to have it as a system function, but I'm not sure how. The previous time we discussed about it, we considered it was too complicated. But
well, we could start it off as a function repository function, as we just discussed.
I can try to create some prototype documentation and we discuss it.
Fine. I mean, you could use that name for the function repository. But okay, we still haven't solved the problem of what we're going to do with this function. Oh boy. Okay. So this is a function that I just don't believe in threads through n levels. I don't think that is
So Jose, your proposed function can pull the head up as well as down, right?
Yep.
Should it be a threading function at all? Or is it a head transpose function? That sounds crazy. Head transpose sounds totally crazy. Okay, the minimal case takes f of list x. Well, actually, let's do the general case. List f list x. And that turns it into, and that function, head thread, for example, can take, it's basically deciding what level. Now, what's this going to do? This is going to have to say level, let's say level 3, do it on F.
Right. But it's 3 down for F. So it's a relative change.
Okay.
Because,
all right, why isn't this working? Did I just not define it here? Why isn't that working?
right. Oh, perhaps, yeah, I don't have code for that general case. Yeah.
Okay, fine. Okay,
yeah.
so that was faked before, right? So
Yeah,
this case, all right, so this would be f of list x, I don't actually need that f at the end there. But this is now push it down by 2 levels.
Yes, in that case works, yeah.
Okay. It's some kind of transposition, isn't it? I mean, if we think this second argument is going to be widely used.
Yeah, I think so, because otherwise this would be just thread.
So, Jose, would head thread of that f of list x, comma infinity have meaning? Or does it have to be a finite thing?
Infinity, I would guess it would try to push f as deep as possible through all lists.
Right. I mean, my real question is, if the argument to f was some sort of ragged depth list thing, is there a syntax that would basically push f through whatever levels of list there are?
Yeah, I think until it gets stuck. You're saying, I mean, it's never going to be pushed through something other than list or other than G.
Yeah, for as long as the fundamental rule that is that if there are several arguments, then they all need to have the same head and the same length. And it will go down as much as possible.
Sandra on our live stream is pointing out that insofar as it can both thread and unthread, rethread is a possible name. I'm a bit unconvinced. I think the rethread is very... Oh boy, if I saw that in a piece of code, I wouldn't even know how to read it. Rethread. Everyone might be like Ethelred or something. No, I'm giving a hard time here to this.
I mean, so the case I'm thinking of, Jose, is coming back to geoposition. Right now, so if you have geoposition of list here, comma list here, comma list here, so that you have one.
Okay, so
saying, each level, each time put another level of lists around things.
You're saying this case here,
and now put the last 2 here's inside of a list.
I don't even know what that does. What does that do? Okay, and now you want to say thread that, and who knows what that's going to do. That's wild. Okay.
Right, and so then you do, another thread, possibly, at the second position, and you get a geoposition, list, geoposition, list, right.
Yeah, so the first did too much.
4 geopositions.
What's that?
No, the first did too much.
That's a disaster. Yeah, that was a disaster. That threaded right inside the geoposition.
Oh, right.
That was a blind threading. It didn't know what it was threading.
Right. Yeah, so in that sense, because you can control which function is threading, in this case, your position, and through which, this would be more controllable. But, yeah, I think you're right that infinity should thread as much as possible, and it would thread one level in one case, but not through the other one.
We have a nice whimsical suggestion on the live stream of head transplant. By the time we have a function called that, if you see that on a piece of code, and it's like it's one of those, you are guaranteed not to understand this piece of code.
I was going to say, at that point, you might as well just start giving them, names like Bob.
Well, I don't know about that. But okay. So look, I think there's a meaning to infinity, but the main issue is what on earth? What is really going on in this operation? What is really going on? We are moving the thing up and down. We can think of it as I thought about push head, or pull head, but I think that's no less obscure than head transplant, honestly.
Something involving slide?
No way. These metaphors are incomprehensible to people. I mean, I think that we get away with a few, like sow and reap. We get away with. Yeah, I mean, comment on the live stream about deep thread, but I think that the problem is thread inside is okay. Let's think about thread inside. Question on the live stream about will negative level specs be supported? Yeah, because negative level specs mean move. They aren't negative level specs. They are actually negative head motion. That is, you're moving the head up. So in this case here, although this isn't working yet, -1 would mean move that head up. I mean, honestly, it is sounding more like a head transplant story. I mean, it's moving heads up and down. What's a generalization? I mean, we can't really talk about raise and lower. What is yes, the depth thing. There is a notion of, at what depth is F in here? But that's, the only way to ask that, I think, how do we ask that? We would ask position of that, and it's the length of that, right? Gives what depth F is at in that expression. I don't think we have a function that says what depth does something occur at. It'd actually be a nice function.
Can't you do that with level?
I don't think so, because what level will do is to tell you at a specific level what's there.
Right.
So it's inverse level.
Yes, but that will be a nice, at least function repository function, a thing that finds at what depth. It's a very simple function to write. At what depth a particular thing occurs. Instead of depth, which is the depth of the whole expression. Actually, I'm now curious whether, this is basically an at what depth. Whoops, depth. Boy,
really, this that would be a 2-argument form of depth. Why? No, that's probably not general.
It's not right because the thing. No, it's at what depth. It's like do a sounding, so to speak. What depth does this occur at? As in, no, would be a different thing. This
right,
is.
But what I meant is that sort of depth tells you how deep you can go into the expression in general.
Oh, I see. To find an arbitrary thing in it. I see what you're saying. You're saying, do the depth. If you said this, depth in expr of F, depth in expr of blank is the deepest that you can go, right? The depth gives you always the deepest level that you can go to, right?
Right, +1.
This is saying, what is the deepest level at which F occurs?
Right.
And in general, one could ask for depths, plural, of expr comma F, which would be the list of depths at which F occurs.
Mm-hmm.
Yeah, that's a not totally. Let's at least think about that as a generalization of depth. The deepest level at which F occurs. And this as the list of depths. It's certainly something I've needed a bunch of times.
Right. The question is whether F is a literal or if it's a pattern.
I think it can be a pattern. It's obviously got to be a pattern because otherwise the default case of depth is blank. right? That would be that gives you the max, which is equivalent to. So then ordinary depth, of expa is equivalent to a max of depths of expa comma blank, right?
Actually, in retrospect, given that we have the pattern in count, cases, and position, that seems very natural.
It does. It does. Gosh, how come we have not noticed this for 30 years? This is a good thing. I mean, I've definitely needed this many times. I'm just not really internalized, and I've ended up with a position, and then I've length the position, and so on and so on and so on. All right, so that okay, that's an ILD item. Put it on the side. Let's, and I have to go in a moment here. So, let's see. Regarding negative level specs, I'm in the case of move F to the second deepest level. I see what you're saying. In other words, I see what you're saying. So you're saying that, so there are two different meanings to -2 inside this thread inside function or whatever it's called. One of them is push F up by 2 levels, and the other is make F be 2 levels from the bottom. Right?
Yep.
Because the normal meaning of a negative level would be make F be 2 levels from the bottom. So I think the name, if indeed we're going to mean raise it up 2 levels, then, I mean, that's a new meaning. Then we need a name. Gosh.
Perhaps we can distinguish with an arrow, with a rule, from the second to the third or something like that, if you want to be super specific.
That's possible, except that typically we don't want to know. Typically we just want the relative. Yeah, I agree. I mean, you could imagine that you can say thread inside, so kind of a bizarre thing would be thread inside. If you're giving an F and a G, you could have a blank, and then you could be saying of expa, comma, and then you could say level 2 to level 4, and then you could say blank here. Because if you've given, I mean, at least if it's a monadic function, I mean, it's it's a little obscure. Okay, we have a few suggestions on the live stream here. Okay, someone's pointing out, Matthew is pointing out that the geoposition, if we had rethread of geoposition, or whatever this thing is called, thread inside of geoposition, comma -2, and the -2 meant 2 levels from the bottom, then that would mean that would be the analog of the points sub-property of geoposition. That is, it would always return a collection of valid geopositions which are precisely 2 levels from the bottom because they're geopositions of lists. That's an interesting point. Redistribute, reorganize, restructure, head reconstruct, head redistribute. Yeah. Redistribute head reorganize. Yeah. I mean, the question is whether we want to admit this is about heads. I guess we do. I mean, I think that's I mean, anything that talks about heads has an additional level of obscurity in my book. If we can avoid having to discuss heads, it's all the better.
We had a really hard time translating that into Spanish.
Which one? Which
head? The function head.
Oh gosh. What is it? I just, out of curiosity, not that I know Spanish, but what does it turn into? What's the? We
in the end we used cabecera, which is like the front part of the bed, or the front part of the line, of the bus line, and things like that. It's the beginning of something.
I see. That makes sense.
But we didn't wish to use cabeza, which is the head of a body. So that was a bit strange.
No, that makes sense. I mean, that's like. I mean, I wonder what car and cutter, so to speak, in Lisp, what they yeah. Anyway, Okay, we have not solved this naming problem, but I think we made a lot of progress on this function. Oh dear. Okay, we'll have to come back to this again. Redistribute head is being suggested. Yeah, from level. Yeah, level from and to. I
mean, it's hard coming up with something that can go up and down. Right. I mean, I think of things like elevate or promote but those sort of imply a fixed direction.
Yeah, which is wrong. Yeah, I mean, look, some of the losing names that we've had are things like through and operate, which are head operations that nobody understands. I mean, in the general theory of what we were calling headdresses, which is, modifiers on the head, which we have some, like derivative is a headdress. But I mean, I feel like, by the way, in the generalization of functional stuff, headdresses are part of the future, but I think we have not, too obscure for now. All right, well, it's a little bit frustrating that we haven't managed to nail the name down here, but I think we'll have to let this percolate. And what did we miss from the rest of this meeting?
This was an attempt of discussing a few functions that are still ILD tickets and whether you think they could be now converted into function repository function.
Egyptian fraction, definitely yes. That's an easy one. What is trim? That I don't know. Histogram association, what the heck is that?
It's a version of histogram list that returns an association.
Yeah, it seems okay too. The others I'm not sure about. All right, thanks very much, and thanks to lots of good thoughts on the live stream today. Thank you very much, guys, and look forward to being with you all again soon. All right, see you later.
See ya.
Bye.